Hello students, today we're going to discuss about numerical techniques 2, module 6. In module 6, there are three major topics. The first one is Gauss elimination method and Gauss-Seidal method. The second is trapezoidal rule and Simpson's one-third rule. And the third is Euler's method and Ranguta method. In this section, we are dealing with only two topics, Gauss elimination and Gauss-Seidal method. First, let's discuss about Gauss elimination method. Before learning about Gauss elimination method, let's see how we convert the system of equations to matrix form and finding the rank. Now consider a linear system of equations in n unknowns, say x1, x2, etc., xn. The system of equations are given there. We have to convert this to matrix form. The coefficients of x1, x2, etc., xn is taken as A, and the variables x1, x2, etc., xn is taken as capital X, and the constants on the right hand side b1, b2, etc., bn is taken as capital B. Now we have simplified the linear system to Ax is equal to b, where A is the coefficient matrix, x is the variable matrix, and b is the constant matrix. Now when b is non-zero, Ax is equal to b is called the non-homogeneous equation. And when b is equal to 0, it is called the homogeneous equation. Now let us see the process of solving non-homogeneous equation. The step 1, you have to write the augmented matrix. That is the coefficient matrix A and the constant matrix B as A is to B. Then we convert this matrix to echelon form using only row reduction. After converting to echelon form, that is step 3, identify the rank of the augmented matrix. We usually take that as R. The rank of A is taken as R dash, and the number of unknowns, that is the variables, is taken as N. After that, we identify whether it has unique solution, infinite solution, or no solution. If R is equal to R dash and that is equal to N, the system of equations has unique solution. If R is equal to R dash and if it is less than N, the system of equation has infinite number of solutions. If R not equal to R dash, the system of equation has no solution. Now let us see an example. Solve 5x plus 3y plus z is equal to 2 minus 4y plus 8z equal to minus 3, 10x minus 6y plus 26z is equal to 0. Now this is clearly a non-homogeneous equation. First of all, you have to identify the coefficient matrix A. That is 5, 3, 1, 0, minus 4, 8, 10, minus 6, and 26. Then the variable matrix X, we write that as a column matrix X, Y, Z. And the constant matrix B, that has the right hand side values 2, minus 3, and 0. After identifying the matrix A, X, and B, we write the augmented matrix A is to B. That is the coefficient matrix A along with the constant matrix B. Now, after writing the augmented matrix, we have to convert this to row reduced echelon form. Here we apply only row transformation. After writing the augmented matrix A is to B, the first element should be a non-zero element. Now in this case, it is already a non-zero element 5, and you have to make all the terms below the number 5 as 0 using only the row transformation. Now row 2 is first element is already 0. In row 3 it is 10. You have to make it 0 using row transformation. So new row 3 is row 3 minus 2 row 1. So when you subtract, you will get 0, minus 12, 24, and minus 4 as shown in the matrix. After making all the terms below the 5 as 0, move to the next diagonal element. Here it is minus 4. And you have to make the term below minus 4 as 0 using row transformation and using row 2. So new row 3 is row 3 minus 3 times row 2. And you subtract, you will get 0, 0, 0 and 8 as shown in the matrix. Now it is in the echelon form. The blue colored box, the full matrix, shows the rank of the augmented matrix. And the number of non-zero rows is 3. Therefore, the rank of the augmented matrix A is to B is 3. To get the rank of A, and that is given by that red box. We have 3 by 3 matrix and we have only 2 non-zero rows. Therefore, the rank of A is 2. Now, we have got the rank of the augmented matrix A is to B is equal to R is equal to 3. The rank of A is R dash and that is equal to 2. And the number of unknowns is 3. So clearly R not equal to R dash. So that means there is no solution for the system of equation. Let us consider another example. 8y plus 2z is equal to minus 7. 3x plus 5y plus 2z is equal to 8. 6x plus 2y plus 8z is equal to 26. Now, directly you write the augmented matrix 0, 8, 2, minus 7, 3, 5, 2, 8, 6, 2, 8, 26. Now, the first entry is 0. So, you have to interchange any two rows. Here, I'm going to interchange row 2 and row 1. So, interchange row 2 and row 1. You get a matrix 3, 5, 2, 8. 0, 8, 2 minus 7, 6, 2, 8, 26. And then the first element is non-zero now. You have to make all the terms below that as 0. Second row already the first element is 0. The third element is 6. You have to make that term 0 using row 1. So new row 3 is row 3 minus 2 into row 1. Apply that row transformation, you will get the last row as 0, minus 8, 4 and 10. After completing that step, move to the next diagonal element and that is 8 here. Below the 8, we have to make it 0. That is minus 8 should be made 0 using row transformation and using row 2. So new row 3 is row 3 plus row 2. So that term will become 0. So the last row changes to 0, 0, 6 and 3. After the row reduction, it is converted to echelon form. Now as you see the matrix here, the blue box contains the matrix, the augmented matrix. It has 3 non-zero rows. Therefore, the rank of the augmented matrix is equal to R and that is 3 here. Now the red box contains the matrix A and it has 3 non-zero rows. Therefore, the rank of A is equal to R dash is equal to 3. The number of unknowns or the number of variables here n is 3. So R is equal to R dash and that is equal to n and that is equal to 3. So by this condition, the system of equation has a unique solution. Now, after identifying that it has a unique solution, we are going to use this echelon matrix and convert it back to the system of equation. Now, A is denoted there. There is a simplified form of the Gaussian matrix. We are going to rewrite that as AX is equal to B. Now, we rewrite that as AX is equal to B, where A is the simplified form in the echelon form matrix, where X is XYZ and B is also the simplified form taken from the echelon matrix. After writing in the matrix form AX is equal to B, expand it. So 3 into x plus 5 into y plus 2 into z is equal to 8. Then 0 into x plus 8 into y plus 2 into z equal to minus 7. 0 into x plus 0 into y plus 6 into z equal to 3. Now we are going to solve this system. Z is equal to 1 by 2. Substitute in the second equation. So 8y plus 2 into 1 by 2 is equal to minus 7. Simplify that, you will get y is equal to minus 1. Use z is equal to 1 by 2 and y is equal to minus 1. Substitute in equation number 1 and simplify, you will get x is equal to 4. The solution is x is equal to 4, y equal to minus 1 and z is equal to half. That gives you the unique solution. Another example, example 3. Solve 5x plus 3y plus 7z is equal to 4. 3x plus 26y plus 2z is equal to 9. 7x plus 2y plus 10z is equal to 5. It is a non-homogeneous equation. Directly you write the augmented matrix. A is to B. That is 5, 3, 7 is to 4. 3, 26, 2 is to 9. 7, 2, 10 is to 5. Now the first element 5 is non-zero. And what you have to do is make all the terms below 5 as 0 using row transformation and using the row 1. Now to make 3 0, it is enough to take the LCM of those two terms. That is new row 2 is 5 row 2 minus 3 row 1. Now to make the term 7 0, we have to take the LCM of that. That is new row 3 is 5 row 3 minus 7 row 1. So automatically these two terms will become 0. And so you will get the second row as 0, 121, minus 11 and 33. And the third row becomes 0, minus 11, 1 and 3. After that, the second row you can see a common factor, 11. So new row 2 is 1 by 11 into row 2. So the row 2 reduces to 0, 11, minus 1 and 3. Now, after the first step, move to the next diagonal element, and that is 11. Below the 11, that is minus 11, should be made 0 using row transformation and using row 2. So new row 3 is row 3 plus row 2. So that becomes 0, 0, 0, 0. Now it is in the echelon form. So the rank of the augmented matrix, there are two non-zero rows, therefore the rank is 2. And the rank of the matrix A, there are two non-zero rows, rank is 2. And the number of unknowns, and that is the number of variables, is 3. So R is equal to R dash is equal to 2, and that is less than 3, the number of variables. The system of equations has infinite number of solutions. After identifying that it has infinite number of solutions, we are going to rewrite that in the form Ax is equal to B, where A is the simplified form of the Gaussian matrix taken from the echelon form, X is the variable, and B is the constant. Now expand Ax is equal to B, you will get the equation 5x plus 3y plus 7z is equal to 4, 11y minus z is equal to 3. Now to solve the system of equation, now choose n minus r variables as an arbitrary constants. Here n is 3 and r is 2. So 3 minus 2 is equal to 1. So we can choose any one variable as an arbitrary constant. So let's choose y is equal to k. Substitute in the second equation, you will get 11k minus z is equal to 3. Simplify, you will get z is equal to 11k minus 3. Now substitute y is equal to k, z is equal to 11k minus 3 in the first equation and simplify. 5x plus 3k plus 7 bracket 11k minus 3 equal to 4. Simplify that, you will get x is equal to 5 minus 16k. So the solution is X is equal to 5 minus 16k, y is equal to k, z is equal to 11k minus 3. As k changes, you will get infinite number of solutions. Till now, we were discussing about solving non-homogeneous equation. Now let's see how we solve a homogeneous equation. The process is almost the same as that we did on non-homogeneous equation, except the right hand side b is 0 here. There is a few changes in the condition. If r is equal to r dash is equal to n, the system of equation has a trivial solution. Trivial solution means x is equal to 0, y equal to 0 and z is equal to 0. If r is equal to r dash and that is less than n, the system has infinite number of solutions. We also say that ax is equal to 0 is always solved with a trivial solution or an infinite solution. For a homogeneous equation, there exists a solution always. Now let us consider an example of homogeneous equation. Solve the system of equation 2x plus 3y minus z is equal to 0, x minus y minus 2z equal to 0, 3x plus y plus 3z equal to 0. Clearly, the right hand side is 0. So ax is equal to 0. It is a homogeneous equation. And same as we did for non-homogeneous equation, we had to write the augmented matrix. That is 2, 3, minus 1 is 0. 1, minus 1, minus 2, 0. 3, 1, 3, 0. The first element here is 2 and that is non-zero. Below the 2, we have 1 and 3. You have to make it 0 using row transformation and using row 1. So we take the transformation. New row 2 is 2 row 2 minus row 1 and new row 3 is 2 row 3 minus 3 row 1. So you will get the second row as 0 minus 5 minus 3 0. Third row as 0 minus 7 9 0. Now after the first step, move to the next diagonal and that is minus 5. And you have to make minus 7 0. Below the term that is minus 7, you have to make it 0 using row transformation and using row 2. Now the transformation that we take is new row 3 is 5 row 3 minus 7 row 2. So the third row becomes 0 0 6 6 and 0. So the rank of the augmented matrix is 3. Rank of A is also 3 and the number of variables is also 3. So by the condition, it has a trivial solution. That is x is equal to 0, y equal to 0 and z is equal to 0. Another method that we are discussing is Gauss-Seidal method. Gauss-Seidal method is an iterative method to find the solution of the system of equation. It is also called the method of successive displacement. At the beginning of the problem, we use an initial values of x, y and z and find the values of x, y and z and replace the original value of x, y and z with the new value. Again, we substitute and find the new values of x, y and z and replace the existing value with the new value. That is called successive displacement. Now, before applying this method, make sure the system of equation is diagonally dominant. Now, as you see in this equation, A11 is the coefficient of the first equation and that should be the biggest in that first equation. A22 should be the biggest in the second equation. A33 should be the biggest in the third equation and so on. ANN should be the biggest in the nth equation. That is called diagonally dominant. Now, if it is not in diagonal dominant, rearrange the equation so that it becomes diagonally dominant. Now, an example for Gauss-Seidal method. Solved by Gauss-Seidal method, x plus 10y plus z is equal to 6, 10x plus y plus z is equal to 6, x plus y plus 10z is equal to 6. Now, clearly, it is not diagonally dominant. You see the diagonal marked in red? It is not the maximum values there. So rearrange the equation so that it makes a diagonally dominant system of equation. Now here in the second equation you can see 10x plus y plus z is equal to 6, x plus 10y plus z is equal to 6, x plus y plus 10 is equal to 6. The diagonal elements are the biggest there. So that is the diagonally dominant equation. Now after converting to diagonally dominant, from the first equation find out x. And from the second equation find out y. And from the third equation find out z. From the first equation, you will get x is equal to 6 minus y minus z by 10. And from the second equation, you will get y is equal to 6 minus x minus z by 10. And from the third equation, you will get z is equal to 6 minus x minus y by 10. Now, we usually start the problem with an initial value, say 0, 0, 0, or you can take 1, 1, 1. Now, to find x, substitute for y and z, you will get the value of x. Now, when you find y, replace x with the new x value. And when you find z, replace x and y with the new x and y value. So you will get a new order pair of x, y, and z. And that order pair is used for the second iteration. And the process is continued until both the iteration have the same value. That is, x values will repeat, y values will repeat, and z values will repeat itself. Now in this problem, iteration 1, choose the initial solution as 1, 1, 1. That is x is equal to 1, y is equal to 1, z is equal to 1. Substitute for y and z, you will get x is equal to 6 minus 1 by 10, that is 0.4. That is our new value of x. Find y. 6 minus new value of x, 0.4 minus 1 by 10. That simplifies to 0.46. And that is our new value y. Now use new value of x and new value of y in z. So z is equal to 6 minus 0.4 minus 0.46 by 10. And that is 0.514. That is our new z. Now we have got new values of x, y, and z as 0.4, 0.46, and 0.514. These are the order pairs for the next iteration. Now, the iteration 2, we use the new values 0.4, 0.46, and 0.514. So x is equal to 6 minus new value of y and new value of z by 10. And that is 0.5026. That is our new value of x. That should be used to find y. So y is equal to 6 minus 0.5026 minus 0.514 by 10. So y value becomes 0.4983. So new value of x and new value of y should be used to find z. So z is equal to 6 minus new value of x 0.5026 minus new value of y 0.4983 by 10, and that is 0.4999. So you got a new order pair after the second iteration. So the new order pairs of x, y, z are 0.5026, 0.4983, and 0.4999. These are the new values, and these values are to be used for the third iteration. Iteration 3. We use the previous values 0.5026, 0.4983, and 0.4999. X is equal to 0.5001, and use that value to find y. You will get y as 0.5. Use new value of x 0.5001 and 0.5 to find the value of z. You will get 0.4999. So our new values of x, y, and z is 0.5001, 0.5, 0.4999. Now these are the order pairs that we are going to use for the iteration number 4. So in iteration 4, we use this order pair. So x becomes 0.5, y becomes 0.5, z also becomes 0.5. Now you can see the iteration 3 and 4 are almost equal, 0.5, 0.5, 0.5. So we can stop the process here. So the solution, x is equal to 0.5, y is equal to 0.5 and z is equal to 0.5 is the solution.